Hi, this time I'm speaking and I'm interviewing composer Artemis. She has composed brilliant composition Imitation Game. As I understand, there is used robots and musical robots and artificial intelligence. So maybe you can give like some kind of short history of this piece. Who commissioned and
Yes, so thank you for the invitation, first of all. So the piece is actually part of my doctoral research, and which in turn is part of a larger artistic research project called Interagency and funded by the Austrian Science Fund. And both my doctoral research and this project explore AI and machine learning as a means of enhancing human-machine communication in musical works for instrumentalists and computer and live electronics.
and what is like central message of the work, right?
Right. So I don't know if there is a central message as such, but the piece is really about the negotiation of intentions between the two actors. The two actors in this case are the human and the robotic percussionist. So the piece is based on a reciprocal and conversational interaction between the two. And the idea here is the computer can choose among following the human percussionist's lead, playing something similar, imitating the human, or just initiating musical changes and proposing new sound material. So the robotic percussionist can choose among three interaction scenarios, basically: imitate, repeat, and initiate. And the musician will also follow a non-linear score that allows him to adapt to the robotic percussionist's actions in real time. And so the piece is really based on a dynamic form. So the form of the piece results through these decisions that the musician and the robotic percussionist make in real time. It's a result of the negotiation, the musical negotiation between them.
And can you tell a little bit about robot, right?
About what? Sorry?
About this robot, right?
Robot. Yeah.
How you build it, and then there is understand there is some kind of hardware part, right? And then there is software part, and how you train, what kind of software you use, and how you train the robot to listen and to interact.
Yeah, so the robot is very much a DIY project. I built the hardware and the software for this piece. The hardware is mostly servo motors controlled by an Arduino Uno. And these motors control or move some different mallets and some wire brushes. And then there are also two permanent magnets suspended over a cymbal and controlled by electromagnets underneath, which creates a sort of irregular scraping sound on the cymbal. The software is written in SuperCollider. The neural networks, all the training was done in Python. And essentially, the robot uses a neural network trained to recognize different instruments, so the different types of percussion instruments and different playing techniques, such as strokes, scraping, bowing. So based on this sound event level recognition, the robotic percussionist then calculates some metrics of musical contrast, and these metrics concern larger musical phrases. And then the robotic percussionist just sort of monitors how musical contrast evolves through the piece. So let's say, for example, that rhythmic contrast is constant for a while. This means that the musician has been playing the same rhythm for too long. Then the robotic percussionist is more likely to try to introduce different rhythms, different sound material in order to make their interaction a bit more interesting and a bit more variable. So that's the auditory processing and decision-making stage of the robotic percussionist in a nutshell.
And did you train him, or it was pre-trained before?
So yeah, I trained the robotic percussionist myself with the help of the musician. I have to say that the percussionist who performed this piece is Manuel Alcaraz Clemente. I'm very grateful to him for his participation in this part of the process. And so we would just get together and record a lot of examples of the different classes that we wanted the neural network to recognize. So Manu would play a lot of strokes on the cowbells and a lot of strokes on the cymbals, the same for the bongos. We would use different types of mallets to help the neural network better differentiate. And so, yeah, it was just a process of recording examples, training the neural network, doing some error analysis, and then recording more examples until it reached a level of accuracy that I considered was good enough for the purposes of the piece.
And how big a database you needed to create for training him?
I have to be honest, I don't remember, but it was definitely a few hours of material, because there are two components. There are the different instruments and then the different playing techniques. Yes. So it was definitely a few hours of material, but I don't remember exactly how many training examples that added up to. I have to be honest.
And what kind of software you use for that?
So that was all done in Python. Actually, I programmed the neural network from scratch and did all the training in Python, but the piece is actually running in SuperCollider. So in runtime, it's just running in SuperCollider, which is a programming language specifically for music.
Got it. But as I understand, right? So that you program on your own.
Yes, exactly.
In Python. So you as a composer, to creating this piece, you needed to have some kind of programming skills in Python, right?
I guess you could say that. I mean, I think there would have been an easier way to do this. I don't think that in order to work with machine learning, you have to be able to program your own neural networks in Python. But for me, it's something that I was really interested in. And I really wanted to be able to understand the algorithms. And I thought that I could do that if I was able to program them from scratch. So, and this is because this is not my only piece that involves AI and machine learning. It's something that I have been interested in for a long time now. So, understanding the sort of inner working of the algorithms is very central to my work. And I think it influenced also some of the work I did later. So in this piece, the neural network is doing pretty much something very standard, a normal task for neural networks. But later in my work, I decided that I wanted to explore more the specificities of neural networks, so even the limitations. And recently, I finished a piece dealing with the concept of AI bias, for example. So I think that it is this sort of knowledge of the algorithms and the ability to really go into depth in them that led my compositional thought to these ideas later.
Yes, and as I understand, right, you don't use supervised learning, but you use this neural network learning, right?
So it is supervised learning. So I provided training examples with labels. So I provided the neural network with examples of, I don't know, a certain sound, and then the label that this is, for example, a bongo stroke, or yeah. So, but it is supervised learning. Yeah, it is classification.
And can you tell how you choose the setup, right? Why two percussionists, why one robot, and one second is human?
Right. So if you notice in the video of the piece, the human and the robotic percussionist have basically an almost identical setup. And this is meant to accentuate the symmetrical relationship between them. So this piece is really based on an equal and reciprocal interaction between them, meaning that the form of the piece, what happens next, depends on both the musician and the robotic percussionist. Both can decide to introduce new sound material, to initiate musical changes, and so on. So this setup is sort of mirroring that relationship between them in the piece.
Yes. So the basic idea was just to, as I understand from you, yes, the basic idea was just to somehow engage music robot with musician to interact, right? And then you choose the best possible means, and in this case, you choose both percussionists, right? That was the idea how you came to percussionists.
Do you mean the selection of the instrument, or
instrument?
Well, percussion was a really good, yeah, if you want to work with musical robotics, percussion is really a good way to do that, because it would be much harder to build a robot that plays flute, for example. So yeah, it was, yeah, and it was definitely this idea of putting both the human and the computer sort of on the same domain, you know, that they are both producing acoustic sounds. That was very interesting to me. And again, it has to do with the concept of the piece, which is this equal interaction, this reciprocal interaction between human and machine.
And then can you just can you describe all the process of composing? You start with idea, and what are the basic stages?
Yeah, so it usually starts with an idea. For me, this idea can be quite abstract at first. Then, of course, there was a technical part, which means that, you know, I had to collect sound examples, I had to train the neural networks, and this has to be done before I can start working on the piece, because the piece was really based on this idea of instrument and playing technique recognition. And then I would say that the largest part of the compositional process is a reciprocal process between software and hardware development and artistic experimentation. And this process involved Manu as well, the percussionist. So what I would do during the compositional process is that I would come up with some interaction scenarios for them, some specific behaviors for the robotic percussionist. I would implement them. I would make like a first version of the software. And then I would invite the musician to participate in a naive rehearsal. And a naive rehearsal is basically an improvisation in which the musician is not given any information on how the robotic percussionist is going to respond to his actions. So I just asked him to improvise with the robotic percussionist for 10 minutes. And I collected data from these sessions through observation. So I just observed their interaction, but also a semi-structured interview with the musician and a questionnaire. So in this process, I was interested in sort of exploring any gaps between what I intended and what the musician perceived. So how he perceived, how he interpreted the interaction affordances of the robotic percussionist. And I was also interested in experimenting aesthetically, in just trying out my ideas and seeing if they worked musically, if they needed to be revised. And of course, as part of this process, a lot of these initial ideas were revised, some were rejected, and I even came up with new ideas. So it was really this iterative process of just implementing things, trying them out, and and assessing them aesthetically.
And how you decide what kind of, let's say, on what kind of musical language you need to train him, right? You said balls and etc. Are there was some kind of concept that you need to be a little bit, let's say, use some kind of that particular techniques, or it was how you came out to the idea what kind of language you need to train that robot, right?
I'm not sure I understand what kind of language. You mean the programming language, or I'm not sure?
Musical language.
Musical language for the piece.
Because as I understand, right, it's when you train something, right, and the robot start understand it, then in the interaction, but actually you form like you train him for one musical language or something.
Exactly.
Why is that language?
Yeah, that's interesting. Yeah, I don't know if I can really describe that as language, but I think I understand what you mean. And yes, when I program these things, I have specific interactions in mind, but I also want to see what the musician might discover. So, you know, sometimes we design things for a certain purpose, but then the musician makes something else out of it. So I want to explore that thing, and I think this is also this can really be helpful for creative discovery. So at this point of the compositional process, I have to say I was not super interested in the musician doing what I had planned for the piece, but just doing his own thing and allowing any unintended affordances to emerge and things that I might not have necessarily intended to go this way, but some of them were actually very interesting for the creative process. So there was one instance in particular where during one of these naive rehearsals, the musician mistakenly thought that the robotic percussionist was repeating his actions one by one. So it just so happened that the musician, for example, played a few strokes on the bongos and the computer did the same. And it led him to think that the robotic percussionist was really repeating him. And that was not what the robotic percussionist was doing. It was just coincidence at that moment. But this misinterpretation led the musician to behave in a very specific way and created a very interesting counterpoint between the two. And so this later gave me the idea to create the repeat scenario and integrate it into the composition. So in its final version in the composition, this scenario is just sort of an improvised interaction in which the computer will repeat some of the musician's actions, but not all of them. So, this is just an example of how this collaboration with the musician really informed the compositional process.
Yes. And now, just to correctly understand, right, your piece. So let's say this piece is always unique, right? So, for example, if machine start, it can start in any way, right? And then there is, let's say, some kind of improvisational element, so that whether a robot percussionist or human percussionist, right? They can change, and that it's not so much pre-scored. Or yes, Julia.
Exactly. Yeah. So there are some things that are notated, but this is very much the idea, and this is what I'm looking for. It's this element of surprise, and not just for the audience, but also for me, because every time I hear this piece, it's different.
Yes.
It is not that different that you can't recognize it as the same piece anymore, but it is a different experience.
Yes.
And this is something I'm very interested in. And it also has to do with the musician being part of this process, and the musician becomes a co-creator during the performance. It's really, the work is the product of a co-creative effort that involves me as a composer, the musician, and of course the robot, because the decisions and actions that the robotic percussionist performs also shape the performance.
Do you have trained him? I don't know, the robot. There is 18 minutes, right? Let's say, and then there should be some kind of, I don't know, timeline elements, right? When he needs to start ending, or when he needs to start doing more, I don't know, more impressive stuff, right? And then there is beginning, or it's like ongoing.
So there is no specific form to the piece except for the end. So the piece is ended by the robotic percussionist. The performer has no influence on that. It's the robotic percussionist's decision. And the robotic percussionist will end the piece after a certain amount of time. I don't remember, somewhere around 15 minutes. It's not the same at every performance. But for the main body of the piece, there is no predetermined form. So it is really up, or the form is really the result of the in the moment interaction between the two.
And can you imagine the same piece but without artificial intelligence? Let's say pre-programmed algorithms.
Actually, it's a very good question, and no, I cannot imagine, because it would be a very, very different listening experience. It would be a very different concept, and it is the use of machine learning in this piece is not something that is secondary or unimportant. I think that this piece would not have been possible without AI and machine learning, because how else can you teach a computer to distinguish among these perceptual categories, different instruments, different playing techniques? It is actually impossible to describe these in hand-coded rules. So this is one of these cases where the ability of machine learning algorithms to learn by example comes in really handy and enables compositional concepts that otherwise would have been unimaginable. I mean, I really don't think that I would have been able to make the exact same piece without this technology. And I think this also shows that these tools are not just they're not just tools, they're actually more than that. They are part of the creative ideation. They're part of compositional thinking, really.
Mm-hmm. Mm-hmm. And what was the biggest surprise working particularly from machine learning, right? What was the biggest surprise of learnings working on that project?
Are you talking about insights relating to specifically the learning process or the piece in general?
Piece in general, but not from human part, right? Not from human percussionists, but what you learn from this machine learning percussionists.
What have I learned from the machine learning?
Yes.
So it was actually, I learned a lot in this process. There were some things that were related to the machine learning part, but I think they are more technical and less interesting. But I learned a lot by trying to some degree, to some extent, simulate aesthetically informed decisions that humans make when they play music with each other. And I'm not saying that the robotic percussionist in this case fully simulates what a musician would do in this situation, but it creates the illusion of this sort of agency that humans have in music making. And, I've learned a lot by trying to simulate that, all these ideas of following the musician, then for some reason deciding to take the lead and introduce new sound material. On which criteria should these decisions be based, and when do they make sense musically? And all those things are sort of are very hard to describe in propositional terms. They're very hard to describe verbally. It is just a matter of programming and letting the robotic percussionist and the musician interact with each other, observing and just revising the code, correcting things, and so on. So yeah, it is not the type of knowledge that is very easy to describe or put into words, but it was definitely a very important part of the compositional process, just sort of fine-tuning these behaviors to make them look more believable and more musically meaningful.
Yes. And what was the biggest hurdles working with machine learning?
The biggest what?
Hurdles.
I guess it's the amount of data that you need to train a neural network to perform these classification tasks that are very, very easy for a human. So it is very easy for us to tell, for example, that this was a cowbell, this was a bongo. But, for the machine learning algorithm, it takes a considerable amount of data. And, I really remember us recording examples, so Manu and me recording these examples and using all kinds of different mallets, because the sound that you produce when you use a soft mallet on the cowbell is completely different than when you use a hard mallet on the same instrument. So that was definitely, I don't know if it was necessarily a challenge, but it was definitely part of the process, because you have to be aware of the gap between human and computational perception, and you have to try to bridge that gap. So you have to try to find the right features. You have to really analyze your own listening. What do I hear in this sound that makes me think this is a cowbell or a bongo, and try to find the right features to describe these perceptual features to the computer.
So it's like all the labeling is very hard, yes?
Labeling, it is, no, that is not very hard. Feature engineering, that is how just finding the right features, and it definitely involves a lot of iterations of trying out different features and then assessing the accuracy of the model,
Yes.
add new features and seeing if the accuracy improved and so
Can you
on.
give some examples? What features mean for this particular project? What kind of features?
So the features are fairly technical. It's music information retrieval. I don't know that they are very relevant. It's there are a few features that I've used in this. I have used onset detection that just detects if there is an attack in the sound, which should be in the case of stroke, but perhaps not in the case of scraping or other playing techniques. There were also some spectral descriptors, such as MFCs, that describe the timbre of the sound. I mean, I can't say that I remember the exact list of features that I ended up using for the piece, but there's a publication on the piece, so I have detailed everything that is involved in the machine learning part, and also compositional aspects of the piece in that paper.
Maybe like the last question for this interview is what would you suggest, right? Knowing that you have experience, right, with the robot and with machine learning, what would you suggest to young composers who had not such experience, right? What would be your main suggestions?
So let's say for composers, for example, who are interested in machine learning and want to explore this area, I think that nowadays there are so many great tools available. So for example, Rebecca Fibring's Wakinator is an open source software tool, and it's designed specifically for artists. So you don't need any machine learning background. You do not need to go into the effort of programming a neural network from scratch to use machine learning in your works. So I would advise them to start from there, to just start experimenting with these algorithms, training these algorithms. And yeah, I really don't think that it is necessary for artists to be programmers to be able to use machine learning in their work. And at the same time, I think that artists should get more involved with these technologies. And I think that this will have a significant impact, not only on art itself. So for example, what I mentioned before, that these tools really change the way we think, and they really end up shaping our musical thinking, basically. So I don't know how much time we have, if I should go into that, but for example, in my last piece, I explored this concept of AI bias, and I essentially trained a neural network to predict my aesthetic preferences. So I recorded a lot of sound material, and then I labeled it on a scale from 1 to 5 based on how interesting I found this sound material. And then I trained the neural network and integrated this neural network in an interactive music system that interacts with a clarinetist. And so what happens during the piece is that the machine learning algorithm determines whether the computer music system will respond to the musician, whether it will remain silent or propose new sound material. So essentially, the computer has its own aesthetic preferences and acts based on them. And again, this is an example of a compositional concept that was only possible and imaginable because of these tools, because of neural networks and what these algorithms can afford us. And so, yeah, I think that there are two components to this relationship between arts and AI or machine learning. The first is the transformative potential that these algorithms can have on arts, on artistic thought, on artistic practices. And the second is that I think that artistic applications of these tools, artistic applications of AI and machine learning, can really help demystify these tools. So they can really help us understand what these tools can and can't do. What are their capabilities and limitations? So for example, the piece that I just mentioned, bias, is a piece that explores a limitation of machine learning algorithms. So what I wanted to do in this piece was not simulate my aesthetic judgments. It was just let the algorithm make its own assumptions about my judgments, and the algorithm will make some erroneous assumptions. It will make some arbitrary assumptions about my aesthetic judgments. So what we have in the end is not something that is a simulation of my agency. It's a new hybrid agency that is a little bit my bias and a little bit algorithmic bias. So, that's what I find interesting, these compositional concepts that are really informed by the capabilities and limitations of these technologies. And I think they can really help nowadays. They can help us understand what these algorithms can do and also what they can't do.
Yes, thank you very much. It was a very exciting interview and having you on my blog. Thank you very much.
Thank you for the invitation and for the talk.